Morning, everyone. Welcome back to another exciting day in mathematics. How's everyone doing? Good? How was your mini day yesterday? Good extra time for the home play? Let's go. Yeah? Let's go. All right, warm-up number 17 is on the screen. Let's see how you do with that. Copy and go. All right, number one. What'd you get for number one, please? JP, what'd you get? Okay. All right. Diego, Rosas, go. 2y plus 6x squared y minus 1. Okay. Close. If we notice now we are in multiplication, yes? So let me, I'm going to use distributive property just so that I can save space here. Here we go. 3y times 2x squared y, that's 6x squared y squared. 3y times 1, that's 3y. And 3y times negative y, that's negative 3y squared. Next, 4x squared y times 2x squared y, that's positive 8x squared, x to the fourth, y to the second. 4x squared y times 1, that's 4x squared y. And 4x squared y times negative y, that's negative 4x squared y squared. So far so good, yes? All right. And last but not least, negative 2 times all these, we get negative 4x squared y, negative 2, and positive 2y. So far so good, yes? All right. So with that said, let me see. Is there another x squared y squared? Negative x squared y squared right here. So what is 6 minus 4? That's 2x squared y squared. Okay. Next, is there another y? Yes, over here. So what is 3 plus 2? That is 5y. Okay. Next, is there another y squared? No. Let me bring that down. Negative 3y squared. Is there another x to the fourth y squared? No. That's 8x to the fourth y squared. And then is there another 4x squared y? Yes, it's a negative, so these cancel. And then we're left with negative 2. However, we need it in what? Standard form, so the correct answer is 8x to the fourth y squared plus 2x squared y squared minus 3y squared plus 5y minus 2. Hands if you got that by yourself. Let's go. Number 2. Pass someone, Diego. Joe, what'd you get for number 2? Okay, that's all right. Just let's see what you got. Three x squared plus 5x squared minus 5. Close. So we distribute the negative into all of these. So we end up with a positive 3x squared and a positive 1x squared. That's positive 4x squared. Next, positive 5x and a positive, and a negative x. That leaves us with positive 4x. And then we got 6 plus 1, that is 7. Hands if you got that. Okay, good. Number 3, solution set x such that, Joel, pass someone. Jalen, what'd you get? That is correct. Taylor from the corner. Let's go. Diego blocked it. All right. And the last one. Here we go. Here goes a process that I'm still trying to make sure that you're getting this process. I start with 1. Can 1 divide all 3 of them? How about 2? How about 3? How about 4? No. How about 5? 6? Yes. How about 7? 8? 9? 10. And I'll stop right there. So the greatest one is 6. Hands if you got that. All right. So copy the agenda for today. And today, guys, yes. Yes, please. Warm-up number 17. Today we are ending our travel through multiplication. And let's see, just to kind of like go through what we did with polynomials. We classified them when we started. Then we did addition and subtraction. Is that correct? Then we spent a bunch of time with multiplication, different ways and different identities and such. Today's the last one on multiplication, and it's on the binomial theorem. I'll elaborate on that in a little bit. And your home plate for tonight is pages 303 to 304, evens only. Now for those 2 pages, they go from numbers 1 all the way to 18 only. But since you're doing only evens, how many are you doing tonight? 9, yes, half of them. Half of 18 is 9. All right? And that one's already in Canvas, so you can go and get that. And reminder, again, it's going to be recorded again on the video. Tutoring started on Tuesday. Today's tutoring after school at 3:30. That gives you time to go to the restroom or whatever, make a pit stop somewhere, get here at 3:30. And what do we do in tutoring? We finish the home plate. All right? So, with that said, no Nearpod code. You did have a home plate, yes? That was my gift from me to you. Yeah? Good practice? Yeah. You're like, yes, let's go. All right. So once again, home plate for tonight, 303, 304, evens only. And some of you are like, Mr. Q, can I just turn it in? No, it's a gift from me to you. Yeah? No, you keep it. All right. Oh, that's good. You keep it. All right, get a Cornell note ready, and it reads, I can multiply polynomials. Today is the last lesson on multiplication. I can multiply polynomials. Now, I hope so far on our Algebra 2 course, when we started the school year, I've been giving you home play every day, pretty much. And you've noticed that the warm-ups build up to the lesson that's coming up. That's why I introduced little skills in that you need to be practicing. And for those of you that were maybe missing like about a week or so, that you had other things going on, I don't know what, make sure you're going to the YouTube channel, watching the videos, because they all build up. And today you're going to see how all that we've been doing are going to build up to today. And we need to really think about whatever we're going to do today outside of the box. Does that make sense? So, check this out. So what's tomorrow? Friday? So if tomorrow, just in case I was to ask you to get a blank sheet of paper and write down the definition of polynomials, tell your neighbor the definition of polynomials. Some of you are like, Mr. Q, bring it. We got this. We got this, right? All right, so that's why we don't need the Freire model, right? We already have that, okay? So now let me elaborate on today. Ready? Writing utensils down, look up to the screen. Today is going to have to do with patterns. Again, we covered some identities, but now we're going to go to a different pattern. Now check this out. I already talked about this the first week that we met. I said, guys, a lot of us have math embedded in us, all of us. And companies use that against us to sell us stuff because that's what we have. We have math inside of us. Math is everywhere. I think I probably told you that everywhere you go there's rectangles, right? So if you look around the room, rectangles. You look in your pocket, your ID, rectangle. Phone, tablet, computers, doors, rectangles. Why? Because it deals with nature and mathematics. Let me show you some more nature. Look up. Mathematics. They all have patterns. Start from the center. Sketch in your noodle a triangle. Start turning it and making it grow and look at the patterns it forms. It does it with a cauliflower, it does it with a sunflower, and it does it with some kind of flower. And a shell. I'm going to focus on the shell. Let me show you how it grows mathematically. And guess what? All of that is embedded in us because we also have math in us. That's why companies are going now with, reading your digits. There's stores in LA. You guys already know that there's stores now that you can actually put your palm in a crystal ball. You walk in, and then you get a basket, get whatever you need, and you just walk out. No longer like people charging you, no longer you doing the automatic thing. With your palm, they charge automatically bank accounts. Isn't that crazy? Why? Because it all has to do with math. Today, we're going to talk about a pattern that was discovered by a mathematician known as Pascal. He came up with a triangle known as the Pascal triangle. It requires a pattern. Look up. You don't need to copy this. There's a triangle. Do you guys see it? It looks like a honeycomb, but it is a triangle. And he discovered a pattern that if he keeps the ones consistent at the ends of the triangle, he can fill in the gap in here with a pattern. Now, I have some animation. Here goes the animation. Look up to the screen. Here it goes again. This is known as a Pascal triangle, and it continues to grow. Now, why is this so important? Because this pattern we're going to use today to multiply binomials. In order to multiply binomials using the Pascal triangle, that's known as the Binomial Theorem. So check this out. First, let me explain what we're looking at. What we're looking at is that we start with the number 1. So if I was to ask you to sketch this without the honeycombs, it would look like this. 1. Then 1, 1. And then 1. 1 plus 1 is 2, and then I ended with 1. Then you go to the next row. Start with 1. What is 1 plus 2? 3. 2 plus 1? 3, and then you ended with 1. And start all over. 1. What is 1 plus 3? 4. What is 3 plus 3? 6. 3 plus 1? 4, and then you ended with 1. So each of these steps are known as rows. The very first number that we start with, since there's no addition and no pattern, just starting with a number, this is known as row 0. That means that this row is row 1, this one is row 2, this one is row 3, and this one is row 4. Are we there so far? So, on your paper, I want you to write Pascal's triangle and copy this, what I just did here. Copy that, I'll give you some time. And go. All right, so once again, just to make sure that we understand what we're looking at, this is known as the Pascal triangle. It starts with the number 1, that's row 0. This one, now that we go from here, it grows to 1, 1, and this is known as row 1. This one starts with 1. You combine these to give us the middle spot, and then you ended with 1. This is row 2, this is row 3, and this is row 4. So far so good? All right. Now that you know the pattern, I want you to give me row 5. Row 5. All right, check with the neighbor, see what they got. Hopefully they have something like yours. All right, let's see what you get, Jessica. Go. 1, 5, 10, 10, 5, 1. Hands if you got that. That is correct. Okay, now that we got the pattern, show me row 6. All right, for the sake of time, here goes. I start with 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then we end with 1. Hands if you got that. Okay, we got the pattern, right? All right. So do me a favor, could I get the first person in each row? Go get a blank sheet of paper for each person in your row. They're over there. I'll pause this really quick. All right, so you all close your notes, yes? Okay, let's go to the top of the paper. And for those of you watching on YouTube, get a blank sheet of paper so we can practice writing our Pascal triangle. So let's do this one together. Ready? Here we go. We start with what? 1, and then 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1, and then 1, 4, 6, 4, 1, and we'll do one more. 1, 5, 10, 10, 5, 1. Stop right there. Okay. Turn your paper over. Do it again by yourself. Pascal triangle. Stop at row 5. All right. Check your work. There it is. Hands if you got that. Okay. Fold your paper over that one. And you're going to have now a blank in front of you again. Sketch me the Pascal triangle only to row 4. Row 4. All right. Check with the neighbor, see what they got. Row 4. All right. I think we got it, yes? From 1 to 5, how comfortable are you with the Pascal triangle? We got this, okay? Now, the reason I wanted you to get it in here, the pattern, because we're going to need it for this next part of the session. So, before I go to the next part, here it goes. I want to clarify this. Look up to the screen. Let me start down here. X to the first power is X. Do you agree with that? Yeah, because if I was to give you this without an exponent, we just put a 1 and it becomes that. That means that 2 to the first is what? 2. That means if I was to give you a star to the first power, what do I get? Everybody understands, right? All right, let's go to this one. X to the 0 power is 1. 2 to the 0 power is 1. 23 to the 0 power is star to the 0 power is anything to the 0 power is. If I give you something in parentheses to the 0 power is, okay, we got it, right? Okay. Don't copy this next, look up. Tell your neighbor what the product of this is. Correct answer is 1. Tell your neighbor the product of this one. Yeah, x plus y. Okay. See what I did? I just kind of like tweaked your noodle just so that you can see that. Now, here goes the real, I'm not going to say test, I'm going to say partay. This is an identity that you should have memorized already. Right? It's one of the 3. Is that correct? All right. So think about it. What's the product of that? Tell your neighbor, please. What's the product of that? Yeah, x squared plus 2xy plus y squared. Now, how do we get that? It's a pattern. But if I was to ask you to multiply this, you would do what? X plus y times x plus y, distributive property, combine, and we end up with what? This, right? So what other patterns haven't I shown you? I haven't shown you this one. I haven't shown you this one. I haven't shown you that one, and so on and so forth, right? But can you agree that if I was to ask you to multiply those, we're going to end up with a big polynomial because we start adding a bunch of binomials and multiplying them, yes? Today I'm going to show you how to multiply these without multiplying. We're going to, well, without multiplying that traditional way. We're going to use the Pascal triangle and using patterns to just write the product. That's what we know as binomial theorem. All right, copy this one, please. Example MJQ on your notes. You don't need the blank one anymore. That was just for practice for us. So it reads, find the product using the binomial theorem, then check by multiplying using any method. Today we're not going to check. I just want us to get through the process of multiplying using the binomial theorem. Given x minus y cubed. Copy the instructions, please. Use them. All right. So, with that said, writing utensils down, look up to the screen. I'm going to start this one, then I'll ask you to copy. Please don't write anything while I'm speaking or else you're going to get lost, for sure. Or like you guys say, 100%. Okay, y'all ready? All right, here we go. Look up to the screen. Oh my goodness. Check this out, I'm off. Look up to the screen, and people are like, all right, here it goes again. Look up to the screen. Ready? Here it goes. First things first. I'm going to do a think aloud so you guys can hear what I'm thinking. Ready? I need to multiply this using a pattern known as the binomial theorem. In order to do so, I need the Pascal triangle. How does that go? Well, first, I need to check the exponent on the binomial. The exponent is 3. Why do I need to know that? Because that tells me that on the triangle, I'm in row 3. So right away, my brain goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Are we there so far? Don't copy yet. Why is that so important, Mr. Q? Well, because we're going to use row 3 as coefficients, which means each number is a term. How many terms do you see now? 4. So our product, end product, has 4 terms. 1 space, plus 3, space, plus 3, space, plus 1. So far, so good? Okay. Don't copy it. I'll give you time. Look up to the screen. I'm going to start with the first term. And I'm going to go x to the third power. But as it goes at each term, it loses a degree. X to the second, x to the first, x to the 0. The second term, negative y to the 0. So if this one started with the highest and it decreased, this one starts with the lowest and it increases. Negative y to the first, negative y to the second, and negative y to the third. Copy that, please. Woo! Let's go! Let's go! Huh? Almost. Yeah, copy that really quick and we'll finish it together. So, just to recap. First thing I did is check the exponent. Why? Because that tells me which row I'm going to use as coefficients, yes? I take each one of these, I space them out with a plus in between so they can be a term. Then I go back to the binomial. I start with the first term and start with the highest degree, write it. On the next term it decreases, on the next term it decreases, and on the next term it decreases. I go with the second term and I start with the lowest degree. On the next term it increases, increases, and increases. All right. Now that I'm there, writing utensils down, look up to the screen. Now I'm at the point of just simplifying. I'm going to start with term 1. Here we go. Pay attention to this part. What is negative y to the 0? 1. And there's multiplication, right? So what is 1 times 1? Times x cubed, x cubed. Copy that. You're like, what? I know, right? Am I right? Am I right? All right, let's do the next term together. So I'm going to box it like this. I want to start with a negative y. What is negative y to the first power? I'm going to write it right above. Negative y, yes? But now we have a negative here. So let's get rid of the negative. What is negative times a positive? Negative, so bring that down. Is there another number other than 3? No, bring it down. Bring the x squared, and then what was left over here that we took away the negative? We're left with the y. Let's go to the next term. And this one was there, okay? Again, what is negative y squared? Positive y to the second power. All right. Since we don't have any negatives or any other numbers, I'm going to bring down the plus 3, yes? And then x to the first, and then y to the second. Yeah, because this became that, right? And then we just bring it down. Last but not least, what is negative y to the third power? Negative y to the third power is negative y to the third. So now we have a negative, so what is negative times a positive? Negative. Question, what is x to the 0 power? So what is 1 times 1? 1, and that leaves us with y to the third. Oh, because when we do negative times a negative times a negative, when it's an odd exponent, it's always a negative. When it's an even, it's a positive. Okay? Yeah, thank you. All right. So this one is here, and this one is there, and this is our product. From 1 to 5, how control? Are you with that so far? 5 fours, okay. All right. So let's see if you can do this one by yourself. Example, super cube, parentheses, x minus a to the fourth power, I'll give you a head start, and then we'll go over it together. Go. All right, so let's see where we're at. First thing we did was to check the exponent. The exponent is 4. That means we're in row 4. So if I add one more row here, it would be, here, let me write it again, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Is that correct? How many terms are we going to have at the end? 5 now. Okay, so let me scoot up. We got 1 space plus 4 space plus 6 space plus 4 space plus 1. Hands if you're up to right there. Okay? Next, I start with my first term, x. And what do I write? X to the 4. For this term, x to the third, x to the second, x to the first, and x to the 0. So far so good? Next, negative a to the 0, yes. Negative a to the first, negative a to the second, negative a to the third, and negative a to the fourth. All right, let's simplify. Let's see what we get. What is negative a to the 0? 1. 1 times 1 is 1. That leaves us with x to the 4th. Bless you. Next, what is negative a times 1? That's negative a. Now we have a negative, so that means negative times the positive is a negative. Bring down the 4, bring down the x cubed, and bring down the a. We're done with this one. Let's go to this one. What is negative a squared? Positive a squared. That became that. So, since we don't have any negatives, bring down the positive 6, the x squared, and the a squared. Next, what is negative a cubed? It's an odd number, so it's negative a to the third. But now we have a negative, so negative times a positive is a negative. Bring down the 4, x to the first, and a cubed. And last but not least, what is negative a to the 4th power? It's an even number, so this is a to the, or positive a to the 4th, yes? So, what is x to the 0? 1 times 1 times a to the 4th is positive a to the 4th. All right? Now, technically we're done, but this is the only one that you need to make sure you go and double check, look up. I start with this one. Are there any other variables in the first term? No, so it's x to the 4th. Are there any variables here that are different? Yes, x and a. What do you guys notice? It's out of order, so we do negative 4ax cubed. Then we go to this one. This one is 6a squared x squared. This one, negative a cubed x to the, oh, I'm sorry. I skipped the 4. Negative 4a cubed x to the first. And then we finalize it with a to the 4. Woo, let's go. From 1 to 5, how comfortable are you with these? 5, 5, 5 fours? Yeah. All right. Shall we crank it up a little bit? If you notice, these two, I didn't use any numbers in the binomial. You guys notice that? All right. Example 3. Copy this one. X minus 2 cubed. And like Obi-Wan Kenobi said to Luke Skywalker, use the Force, Luke. So I'll give you a head start. See if you can set that up. Start simplifying. See what you see, and then I'll come right after. Okay? X minus 2 cubed. Copy and go. All right. Let's see. how we did. For the sake of time, here goes the process. First thing you did, checked on the exponent, it was 3. We're in row 3 of the Pascal. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. We use those as coefficients. 1 space, plus 3 space, plus 3 space, plus 1. So far so good? Next, start with my first term to the third power. So it's x to the third. Next term, x to the second. Next term, x to the first. Last term, x to the 0. From there, I go to my second term of the binomial, and I go negative 2 to the 0, negative 2 to the first, negative 2 to the second, and negative 2 to the third. So, I simplify. Start with this one. What is negative 2 to the 0? 1. What is 1 times 1? 1, and that leaves us with x cubed. Next, what is negative 2 to the first power? Negative 2, is that correct? So now I have a negative. So negative times a positive is a negative. 2 times 3 is 6, x to the second. We're done with the second term. What is negative 2 squared? Positive 4. So, since we don't have any negatives, we just multiply the numbers. What is 4 times 3? 12. Bring down x to the first. We're done with the third one. Go to the last one. What is negative 2 times negative 2 times negative 2, or negative 2 cubed? Negative 8. Now we have a negative, so negative times a positive is a negative. What is x to the 0? 1. So what is 1 times 1 times 8? 8, and we are done. Woo! Let's go. How about them apples? Yes? We good? From 1 to 5, how comfortable are you with these? All right. Shall we crank it up a little bit? Yes, question. Oh, 5? Okay. All right, last one. Copy this. Too easy. Too easy. Copy that one. 2x minus 1 to the fourth power. All right? I want you just to set it up. You don't have to simplify it. I just want to make sure that you write the entire setup correctly. Copy and go. All right, for the sake of time, you went 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. But we are in row 4, so it's 1, 4, 6, 4, 1. So we write 1 space plus 4 space plus 6 space plus 4 space plus 1. So far so good? And then, what is my first term? 2x. So we write 2x to the fourth power, then 2x to the third, 2x to the second, 2x to the first, and 2x to the 0. And if you got that by yourself, yeah. And then from there, the last term of the binomial, negative 1 to the 0, negative 1 to the 1, negative 1 to the second, negative 1 to the third, and negative 1 to the fourth. And then the next is just to simplify. From 1 to 5, how comfortable are you with this? Yeah, 5, 5, 5. So we'll stop right there. All right, guys, your home plate, once again, make sure you go to Canvas, get that from there. You're doing events tonight. Tutoring after school, be there or be elsewhere. Yeah. Have a good one, guys. See you guys tomorrow. Bye.